In the previous video, we saw how to find the inverse of a general n by n matrix, square matrix. In this video, we want to look specifically at the 2 by 2 matrix. There's a special formula that we can use that makes the process of finding the inverse much more straightforward than that process that we saw previously. But we're going to use that method to find a general formula for this 2 by 2 matrix. Now, not every square matrix will have an inverse. We'll talk about that. But if it does have an inverse, we can use this formula that we're about to derive. Now, we're going to start out by working with a general 2 by 2 square matrix. Something general to where we're not giving any numbers to the matrix. We're just using letters to represent each entry, A, B, C, D. And we want to use the previous method to find the formula, okay? So remember that previous formula, what we had done is we set up the augmented matrix with the identity matrix. And we went through the process of writing this in row reduced form so that we can find the inverse. So we're working with letters. It may look and feel different, but it's the same process as what we've done before, just working with letters instead of numbers, all right? So the first step is we want that first entry in the first column to be 1, right? It's an A right now, so I can multiply by 1 over A to get that to be a 1. Okay, so I'm multiplying by 1 over A, multiplying row 1 times 1 over A. Okay, so A times 1 over A is 1. B times 1 over A is B over A. On the right-hand side, that's 1 times 1 over A, and 0 times 1 over A. All right, so now everything else in column 1 should be zeros. So I've got that C in my second entry in the first column. I want that to be 0. How do I get that to be 0? I multiply the row 1 by its additive inverse. So that is row 2 plus a negative C times row 1. All right, so let's come over to the side, do some scratch work here. So row 2 plus a negative C times row 1. So negative C times B over A is BC over A. And negative C times 1 over A is negative C over A. Add those together. That's 0. D minus BC over A. Now I'm going to get a common denominator here. All right, think of this as D over 1. All right, so I'm going to get a common denominator by multiplying the denominator and the numerator by A. So that's AD minus BC all over A. And 0 plus a negative C over A. 1. AD minus BC over A, negative C over A, and 1. Okay, column 1 is done. So now we want the second entry in the second column to be 1. Okay, and I can do that by multiplying by its multiplicative inverse, which is we're multiplying by this fraction just flipped. Okay, in other words, we are multiplying by A over AD minus BC. That's 1, B over A, 1 over A for row 1. For row 2, that's still 0. Now 1 here. And I'm multiplying this A over AD minus BC times the negative C over A. Make some notes here. When we multiply, those A's are going to cancel out. So we're left with a negative C over AD minus BC. And then times 1. Okay, so now all that's left is to force this B over A to become 0. All right, so to make this B over A to become 0, I'm going to add to row 1 a negative B over A times row 2. Let's see what that looks like. Okay, row 1 minus B over A times row 2. Okay, here's my row 1. And negative B over A times row 2. So that's 0, negative B over A. And that's going to be, all right, I'm multiplying B over A times C over AD minus BC. So that's BC over A times AD minus BC. And B over A times A over AD minus BC, the A's are going to cancel. So we have a B over AD minus BC. That'll be a negative there. Okay, so I am adding these together. 1, 0. When I add these together, more scratch work here, right? I'm adding these. In order to add, I need a common denominator. So I'm going to multiply that first fraction by AD minus BC, both top and bottom. Okay, and so I've got in the numerator AD minus BC times 1, and then plus BC over the common denominator, A times AD minus BC. Now you see that the BC's cancel. And then the A's will cancel as well, leaving me with this D over AD minus BC. And then 0 plus a negative B over AD minus BC. Okay, don't get lost in the letters. Remember, this is going to give us a general formula. You will not have to derive this each time. That's why we're doing it, so that you don't have to do this for every single 2x2 matrix to find the inverse. Okay, because what we have now is we have found the inverse of a general 2x2 square matrix. All right, it's D over AD minus BC, negative B over AD minus BC, negative C over AD minus BC, and A over AD minus BC. Now you may notice that we can take a 1 over AD minus BC out of each of these terms. And then what we have left, the numerators, D, negative B, negative C, and A is the inverse, right? So this is my inverse. This is the formula that you'll see for the inverse. So if A is the matrix A, B, C, D, then its inverse will be 1 over AD minus BC times the matrix D, negative B, negative C, and A. Notice the relationship between these. Right? Notice here that this A and the D switch places. Or you got A and D, and then D and A. And also notice that the B and the C stayed where they're at, but they changed signs. All right, so that's our formula. Now let's look at a specific example to where we're using this formula. So we have the matrix A, 1, 2, negative 1, 3. Let's find the inverse of this matrix, assuming that it exists. We said that it doesn't always exist. Okay, but if it does exist, we can find the inverse using this formula that we just derived previously. And in this case, A is 1, B is 2, C is negative 1, and D is 3. Okay, so the inverse will be 1 over 1 times 3 minus 2 times negative 1. And we switch the A and the D. And we take the opposite sign of B and C. And this number out here, this 1 over AD minus BC, that's what's referred to as the determinant. The AD minus BC, okay? And the inverse will exist as long as the determinant is not 0. We call that a non-singular matrix if the determinant is not 0. Okay. And in this case, it is true that the determinant is not 0, because what we have here, we have 1 times 3 minus 2 times negative 1. 1 times 3 is 3. 2 times negative 1 is a negative 2. So 3 minus a negative 2, that becomes a 5. So we have this 1/5 out in front. And I'm going to distribute this 1/5, right? This using the scalar product, scalar multiplication, multiplying everything, every entry by 1/5. So that's 3/5, negative 2/5, 1/5, and 1/5 is my inverse. And we say that the inverse does not exist if the determinant is 0, right? Do you know why? Right, because if the determinant is AD minus BC, and if that were to be 0, you cannot divide 1 by 0. So therefore, in that case, the inverse would not exist. Now, in our application problems in business, we are not really interested in the cases to where the inverse does not exist, right? We want the inverse to exist. We want these non-singular matrices. We don't want to deal with the singular matrices, the case where the inverse does not exist, where the determinant is equal to 0. We don't care about those cases, so we're primarily sticking with the cases to where the determinant is not 0. But you need to be aware, you may come across some cases, some examples to where the inverse does not exist. Okay, so if you get a determinant that is 0, you would stop there and say the inverse does not exist.